All right, so here's our first example. So if you were to look at this, if I was just looking at the integrand and took the derivative of that, it would be 13. All right, this is just a little side. It would be oh, come on. Four x plus 9 to the 12th power times the 4, right? The fact that we had to use a chain rule means that this is going to be a U substitution. Right? This is not partition. This is just, so what I mentioned is that if you were taking the derivative of what's inside and you need a chain rule, that means that the integral will need a U substitution. So the first thing I mentioned was you look for a parentheses. In this case, there's definitely a parentheses given here. Right? We've got 4x plus 9. So I'm going to call that U. There's nothing special about the variable U. That's just the standard variable used here. All right. And I mentioned that there's going to be a derivative column or component and an integral component. All right, so go ahead and separate them. Ultimately, my goal is to transfer this from letters of U, from letters of X to letters of U. So remember, we let 4x plus 9 be my U variable. So what we have right now is U to the 13th times dx. Right. So again, too many variables. We have a U here and an X there. So what we need to do is get rid of essentially that. Right. We want du, not dx. So this is where the derivative column comes in. And you're going to have to go back and use the dy dx notation. Right. The derivative of u, get du dx equals 4. Right. Take the derivative of both sides. So just like with optimization, if I want to get rid of dx, I want to solve for dx on this side of the curve. Right. So we get du is equal to 4 dx, du over 4 is equal to dx. All right, so now this du over 4 plugs in right here. All right, so now my variables match. Now I'm allowed to integrate. But before I do that, I'm going to go ahead and just pull out this 1/4. All right, so this is going to be 1/4 u to the 14th over 14, and then plus a c. So remember that you're plugging in, or you're adding 1 to the exponent and then dividing by the exponent. We're integrating now. So we take the derivative to get rid of the dx that we don't want. Right, so 14 times 4 is 56. And then last step here, you back substitute. Right, so 4x plus 9 goes in right there. And so it would be my integral. And then if we check, if we do the power rule here, so 1 over 56, 14, 4x plus 9 to the 13th power times the derivative of the inside, the derivative constant is 0. So if you multiply 14 by 4, you get this 56. So this fraction cancels off. You end up with just this, which is the original problem. Right, so for all of these, you can really just take the derivative of the original problem and then check your work. Right. This is, again, this is just little a thought process, right? Just to remind you that you are going to need a U substitution, right? If you have a function inside of a function, this function inside of something to the 13th power, right? So this is my answer right here. And again, don't forget your plus C. Right. So the things I highlighted at the overview, first thing is that look for a U, which is in the parentheses. Right. The next thing is you want your variables to match. Right. So if you have U dx, you want to get rid of the d dx. Right. You can do that by looking at the derivative of the U component. And then once you have your variables matching, you are now allowed to integrate. Until you have a mix of x and y, x and u's, then you have to keep simplifying. All right, let's look at the next example. So this has two sets of parentheses, but the innermost thing is what I'm going to do. X squared plus 2. All right, so that means that we have 3x u to the 5th, and then a dx. All right, so notice that we have, again, a mix of variables. We have x's and u's here. Ultimately, what we want is just the u variables, right? Take the derivative of this part, u dx equals 2x, right? So again, this is the thing I want to get rid of. I want to get rid of dx, but I also want to get rid of 3x. So what I'm going to do is I'm going to solve for dx, and hopefully things will take care of itself. All right, so you cross multiply. Right, we want to solve for dx. Right, so du over 2x plus dx. Right, so that's great because that's going to help us get rid of that. Right, so now I can cancel the x's right here and right here, which allows me to pull out, whoops, which allows me to pull out a 3/2. Right, so now you have u to the 5th du. Right, this is your integral column. This is your derivative column. You use the derivative column to, this is essentially like the constraint equation, right? You plug in for the parentheses, and you also need to solve for the dx. Right, so now I'm ready to integrate. Coefficient u to the 6 over 6 plus a c. And then remember to back substitute. All right, so 3 divided by 12, 3 is the numerator, 6 times 2 is the denominator. That's 1/4. Something to the 6th power plus a constant, and that something happens to be x squared plus 2. Okay. So this would be my answer. And let's check our work. If I took the derivative of this, 1/4 times 6, x squared plus 2 to the 5th power times 2x. All right, so let's see. 2 divided by 4 is 3. That's not even correct. 2 divided by 4 is 1/2. 1/2 times 6 will give me a 3. We still have that x here, and then x squared plus 2 to the 5th. So this matches the integrand. Okay. You don't have to do you don't have to check your work, but if you have time to check it and you get the original, then you know that you did your work correctly. Right. Again, don't forget the plus e at the end. Right. So again, the steps. This first thing is for a u usually in a parentheses. You've got your derivative column, you've got your integral column. You want to make sure that your integral has just one variable, right? We have too many variables in this case. So by working with the derivative column, I converted the integral from terms of x's to terms of u. All right, let's do one more example, and then I'm going to pause this video. All right, this one has, again, a set of parentheses here. So the thing with picking u's is that you want to make sure you pick it so that it cleans up your work. Right, so there's lots of choices here, but this is the innermost function. I'm going to use that. So my integral converts to this. Right, so remember you have your integral column, you have the derivative column. I want to get rid of the dx. I'm going to take the derivative right here. Solve for dx by cross multiplying. Right, and usually when you do this correctly, you're going to start seeing that cleanup process. And if you don't see a cleanup process, you either took the derivative wrong here, or you need to pick a different u. Let me just erase this. Right, so by solving for dx, I plugged in right there. And so now we can start cleaning up. Right, remember you need to clean up before you take the antiderivative. X squareds cancel. 9 and 3 cancels, giving me a integral of 3 over u to the 4th power du. All right, so we went from a complicated equation or integrand to a lot cleaner power rule question, right? So I'm going to pull the 3 out. This is u to the negative 4 du. Right, when you take the antiderivative with something that has a coefficient kind of just tags along, so we might as well just ignore it until the end. That's what I do by pulling the coefficient out. Right, so now we can integrate because everything is just now u's. Right, so we got 3. Don't forget that you're adding. Negative 4 plus 1 is negative 3. All right, so let's clean this up. This is a negative 1 over u cubed plus c. All right, and then don't forget to back substitute. X cubed plus 10. Let me shrink this down. All right, so my integral would be negative 1 u cubed plus 10 to the 4th power plus constant. All right, and if you check your work, let me do the check your work here. All right, this is a negative u cubed plus 10 to the negative 4th power plus c. All right, if you took the derivative of this, you would be at 4. Oops, that's not a u. X cubed plus 10 to the negative. Oh, how did I mess that up? Sorry, guys. This should be a 3. Right, this is a 3 here, so it should be a 3 in the denominator. Right? So this is what you end up with the chain rule. Nope, let's backtrack here. Right, bring the -3 down. Decrease the power by 1. So you get -3 times 3 is positive 9x squared in the numerator, and then this is x cubed plus 10 to the 4th in the denominator, which matches your answer. All right, so sometimes the check your work is a little complicated, but you do end up with your answer here.